In this video, I'm going to talk about even and odd functions. In the previous video, I talked about how to obtain the Fourier series for a general periodic function. So in that lecture, I talk about the cases when we have the integration of even and odd odd functions, the integration will be 0. So in this video, I talk about the property of the definition of even odd function and the property of even odd functions, and show you how you can also use the property of even odd function to simplify the computation with the weights or the parameters used in the Fourier series. Okay, so as a recap, so in the previous lecture I talked about how we write the obtain the Fourier series for a general periodic function. So for a given periodic function f of t, which has a fundamental period of 2L, so its Fourier series given by ft, which is equal to a0 plus summation from n equal to 1 to n goes to infinity of an cosine n pi t over L plus bn times sine n pi t divided by L. So here the parameters are all the weights a0, an, and bn defined as this. Here this a0 is just for one parameter over here, and an, this holds true for n from 1 to infinity. Also for bn, this holds true for n from 1 to infinity. Okay, if you don't know how to compute this, how we obtain this, you can watch my previous video. So our observation is, so a lot of time we have to integrate this function from negative L to positive L. So the computation of this a0, an, and bn actually depends on the property of the ft. For some functions, it's easier to calculate. From the example in the previous slide, as in the previous video, so some of the parameters or weights a0, an could be 0. Okay, so the reason that could be 0 because the function is odd function. Okay. So as a matter of fact, for the even odd functions, the odd function is a computational integral over negative and positive is always quite simple. Okay, because if I look at this one, if I have even odd functions, typically you have, this is what I mean by odd function. I'll give you a definition before, okay, later. So the odd function's integration will be basically simple. It's just 0. Okay, if I odd function, the integration is just 0. So this which makes a computation really very simple. So we don't have to go over the very complex computation to figure out the integration. Okay. So the first question: what are odd and even functions? Okay. So here's a formula that, and also the second question is how can we simplify this computation of all the parameters an, a0, and bn for odd and even functions. That's the main purpose for this video. Okay, now if we start with the first question, so what are the even and odd functions? So this is the definition of odd function. The odd function ft is odd function if ft is equal to the negative of f negative t. Okay, well this basically means, okay, if I draw a picture to show what's going to happen. For example, if you have ft, some point defined this ft over here. So this is t, of course, this is ft. The value at this point, this is give you, let's say this is 5, and for this t is 1. Now when you get to change the t to negative 1, this will be negative 5. Okay, that's what this means, is odd function. So for example, if ft is sine t, so if we put this is, we can check if it's an odd function. So check is an odd function, we just have to verify this. If ft, we just do this. This one is equal to, say, f negative t is negative ft. That's the same because you can pull the negative sign to the left hand side. Okay. So we just to check f negative t. So we should replace every t by its negative sign, which means I have sine negative t. Sine negative is negative sine t, of course. Okay. So because sine t is ft, okay, so it's negative ft. So this is true. According to here, f negative t is equal to negative ft. Okay. And the next example is, what if I have ft which is sine t plus 1, okay, to see if it's an odd function. To verify, we use the same, follow the same procedure. we do f negative t, which means we replace every t by negative t. Okay, which means I replace sign inside t inside the sign notation is sign negative t, changes t to negative t. It's sign negative t plus 1, which equals to negative sign t plus 1. So here, does this one equal to this one? If it's odd function, this one has to be equal to f negative ft, right? Which means the negative ft is sine t plus 1, which is negative sine t minus 1, right? But this is not equal to that. So that's why this is not equal to negative ft, right? Because negative ft is negative sine t minus 1. But here we have f negative is negative sine t plus 1. So they're not equal, which means this is not an odd function. Okay, this is definitely an odd function. The even function, definitely even function is ft is even if ft is equal to negative ft. Okay, you sort of can see this is if this is t, you have this is a 1, for example. This ft is this ft this here is this is 5. Now if you change it to negative 1, you still have positive 5 as the value ft. So which means sort of symmetric around this y-axis. Okay. So it's symmetric. If you do here, this is ft. Now you must have this to be symmetric. Okay. So that's what the definition of even function. So to check even function, you just replace this t by negative, see if that it doesn't change the value of ft. For example, if ft is cosine t, no, f negative t is cosine negative t, because cosine negative t is cosine t, so which is equal to ft because cosine t is ft, right? So this is even. So what if ft is equal to cosine t plus 1? Okay, so here we do the same thing. We just have to change to verify if f negative t equal to ft, right? So ft negative t is cosine negative t plus 1. Okay, cosine negative t is just cosine t. Cosine t plus 1 is cosine t plus 1, which is the same as previous one, which is equal to ft, right? Which means yes, it's still even. Okay, so there are a few properties for the odd even functions. So if I give you two functions, g1t and g2t, they're even functions, and h1t and h2t, they're odd functions. Okay, so first of all, the product is to g1 and g2, the product is even function. The reason is pretty straightforward. If I define this product as g sub t, the big G of t, and if I use the same definition of the odd function, which even function, which is g negative t, is I have replaced all t by its negative sign. The g1 negative t times g2 negative t, because g1 negative t is g1t and g2 negative t is g2t, so the product that's the same as gt. So this is even function. Should say this. So second one is h1t and h2t. The product h1t times is also an even function. The idea is quite similar to as the previous one. So if I define this ht to be the product of h1t times h2t of an h2t, so the h negative t is h1 negative t times h2 negative t, which is this one is an odd function. So this is negative h1t times negative h2t, right? Because negative will cancel out, so it's the same as h1t times h2t, which is ht, which means this is even function. So the first property set, two property sets, the product of two even function or two odd functions, they are always even. Okay. The third property says g1t times h2t is odd function. You can also say, hey, g1t h1t is odd function, right? Or I can also say g2t h1t is odd, and g2t h2t is odd function. Basically what it means, a product of an even function, odd function, is odd. Okay. The fourth property says g1t plus g2t is even. So the product, the sum of two even functions is still even. This is pretty straightforward. So because it's g1 negative t plus g1 g2 negative t is the same as g1t plus g2t, right? So it doesn't change. It doesn't change. Change negative doesn't change. And h1t plus h2t, okay, h1t h2t, they are odd functions. So the sum is also odd functions. And the g1t plus g2 h1t. So g1 h1 they are G1 is odd, even, and H1 is odd. So the product, the sum of the even function and odd function is neither even nor odd. Typically, that's the case. Okay. This also applies to the example. If you remember, the example I give you right over here is the sine t plus 1. Okay, you can consider this as sine t plus 1 is a sine t plus 1. Okay, sine t is odd function and 1 is an even function. Okay, why 1 is an even function? Let's say ft is 1. Is this even or odd? You can say f negative t, because it doesn't matter for every t is always 1. Of course, this is equal to ft, right? So that's why this is even. So the odd plus even, this typically is neither even nor odd. Okay. So this is the first part of this even odd function. So which is I show you what are even and odd functions. So at least you can use the definition to verify if a function is an even or odd function. So in the next video, I'll talk about how can we use the property of even odd function to simplify the computation of the weights a0, a, and bn in the Fourier series of a periodic function.